So let us see some examples that will express some properties of real numbers. So the example is that let a is greater than 0, b is greater than 0, then a and b are real numbers which are both positive, then we can have the relation between these two real numbers. A less than b will implies that a square is less than b square, and it will also imply that square root of a is less than square root of b. So this can be the relation between real numbers a and b if one of them is whole. So the other way the statements are also true. So how to solve this? So let us consider a is positive number, b is positive number, right? So we consider a less than b. If we consider a is less than b, as a is positive, b is positive, so we can have their addition to be positive. So a plus b, or we can say b plus a, both are positive. So a plus b is also positive because a is positive, b is positive. So addition of two positive real numbers have to be positive. Now we have considered a is less than b. So this implies that if a is less than b, so we can have the difference b minus a to be positive, right? Therefore, if I consider this quantity b square minus a square, so what the quantity will be? So by factorization I can write it as b plus a into b minus a. But from this both the statements I know that if a is less than b, then a plus b, this quantity, is positive. B minus a, this quantity, is positive. So if both the quantities are positive, their product has to be positive, right? So this thing should be positive. It means what? B square minus a square should be positive. That is, a square is less than b square. So it is what we wish to show. That means we have shown that if a is less than b, then a square is less than b square. So conversely, if I suppose a square is less than b square, so does it imply the converse part? So if a square is less than b square, it means b square minus a square is positive, right? B square minus a square is positive. Then b square minus a square, so I can write it as b minus a into b plus a. The same way, as we consider it should be positive, and we know that a plus b is positive. A plus b is positive. Why? Since a is positive and b is positive, so their addition has to be positive. So this thing is positive and one of the factor is positive, so other factor should be also positive, right? Product of two things is positive when both the quantities are positive or both the quantities are negative. But the case of negative should not be there because a plus b is conformly positive. So we must have b minus a to be positive. that is A is less than B. So we have shown this part. Therefore, A square is less than B square will also imply that A is less than B. So it is what we wish to show, the relation between first two inequality. Now the next part, as a next part, we know that we have considered A is positive, B is positive, then their positive square roots. Square root of A should be positive, square root of B should be positive. And as these are positive real numbers, so their addition has to be positive. So square root of A plus square root of B must be positive. Square root of A plus square root of B must be positive. Therefore, if A is less than B, A is less than B, that means if B minus A is greater than 0, so I can write this B minus A as square root of B plus square root of A into square root of B minus square root of A. As it is positive, so what we can say that from this? So from this we can say that as this quantity is positive, that means the product of two quantities is positive and one of the quantity root A plus root B is positive, so other quantity has to be positive. So this implies that root B minus root A, it should be positive. That is what we have shown. A less than B will imply that it means root A is less than root B. Right? And conversely, other part, and if we consider root A is less than root B, so then what happened? That means root of B minus root of A is positive. So then B minus A, which is to be root B plus root A into root B minus root A, as this quantity is positive and this is already positive because root A is positive, root B is positive, so their addition has to be positive. So product of two positive quantities will be a positive quantity. So we get B minus A is greater than 0. It means that is A is less than B. So this is the other part, that if we consider root A is less than root B, so it implies that A is less than B. So we have shown that if for real numbers A greater than 0, B greater than 0, these things are equivalent. A less than B will imply A square less than B square, and the converse is also true. Similar things, this also imply square root of A is less than square root of B, and similarly the converse also holds for this case. So similarly to this example, similarly for A greater equal 0, B greater equal 0, so we have made the restriction loose here. Here it is A is strictly greater than 0, B is strictly greater than 0. Here A is greater equal 0, B is greater equal 0. Then for this loose condition of the restriction, we can have A less equal B and you can deduce it from by using the above result. A square will be less equal b square. This will also imply square root of a less equal square root of b. Right. So now let us see some other example, which is nothing but some result with associated with real numbers. So let us consider arithmetic and geometric mean. Inequality. So what does mean a arithmetic mean? So let a is positive integer, b is positive integer, a is positive real number, b is positive real number, then their arithmetic mean is half times a plus b, or a plus b by 2, and their geometric mean is under root of a into b. Therefore, arithmetic geometric mean in equality is for positive real numbers a and b, and the inequality is square root of a into b is less equal half times a plus b. That means geometric mean is always less equal the arithmetic mean. Geometric mean is always less equal the arithmetic mean. So how to check the result or the property of real numbers? Let we consider a is positive real number, b is positive real number, and suppose they are not same. Why they are not same? So we will check why they are not same. So then a is positive, so the square root should be positive. B is positive, so the positive square root is positive. And then now I consider the difference root a minus root b square. As a is not equal to b, so square root of a should not be equal to square root of b. And they are not same, so I can consider their difference. If they are same, their difference has to be 0, and there is no more case. So this is the difference, and it is square of the difference. So square has to be positive. Now expand the bracket. So it is square root of a square has to be a minus 2 times square root a square root b plus square root b square. So it has to be b, which is positive. And check that, simplify this thing. So it will be 2 times square root of ab is less than a plus b, or simply we can say square root of a into b will be less than half times a plus b. So this is the case if a is not equal to b, because if a is equal to b, so here we will not get any difference other than 0. And if I consider A equal to B, so what happens to the inequality? So equality holds in star, because if A equal to B, so on the left side it is square root of A into B is A, so it will be square root of A square, so it will be A, and right hand side will be half times A plus B is A, so it is half times 2A, so it has to be also A. So in the equations inequality star, the equality will hold, right? So let us go to next result, which is Bernoulli inequality. Bernoulli's inequality. So the statement is that if x is greater than minus 1, if x is greater than minus 1, then 1 plus x raised to n is greater equal 1 plus nx for all natural number n. So it is Bernoulli inequality. If x is greater than minus 1, then this quantity 1 plus x raised to n, the degree n polynomial, will be greater equal 1 plus nx for any natural number n. So we can prove this result by using the mathematical induction. So we use mathematical induction, or simply induction. So what we do in the induction, we check that whether the result is true for n equal to 1. Then we assume the result hold for some n equal to k, and then instantly we deduce the same result from n equal to k to n equal to k plus 1. So let us check whether it holds for n equal to 1. So for n equal to 1, so what happens to the statement star? So I will say the statement is star. So for n equal to 1, it is 1 plus x, and on the right it is 1 plus 1x. So equality holds. So equality holds for n equal to 1. So star, statement star holds for n equal to 1. So let us assume statement star is true or holds for n equal to k, for natural number n equal to k, right? So that means what? It means 1 plus x raised to k is greater equal 1 plus kx, where k is natural number, right? And now we have to consequently deduce the result for n equal to k plus 1 by using this statement. So I can give it number 1. Right? So consider one plus x raised to k plus 1. So I can write it as 1 plus x raised to k into 1 plus x. So by using the equation 1 or statement 1, I know that the result holds for n equal to k. That means 1 plus x raised to k. This quantity is greater equal 1 plus kx. So the quantity is greater equal 1 plus kx into the thing 1 plus x. So what is it? Check the product. It is 1 into 1, 1 plus kx plus x plus kx square. So it will be 1 plus k plus 1x plus kx square. Right. So k is a natural number. So definitely this quantity will be greater equal 1 plus k plus 1 times x, and we are getting, therefore we are getting this thing 1 plus x raised to k plus 1 is greater equal 1 plus k plus 1 to x. So it seems that statement star also holds for n equal to k. So statement star holds for n equal to k plus 1. So we have checked whether it is the same statement star holds for n equal to k. We assume that it is true for, suppose it is true for n equal to k, and consequently we have shown that, we have deduced that the same statement is true for n equal to k plus 1. Therefore, by mathematical induction, the statement star is true. Is true or holds for all natural numbers n. That is, if x is greater than minus 1, then 1 plus x raised to n will be always greater equal 1 plus x nx, and it is true for all natural number n. So we stop here.